Hello. Okay, so now you can see how Milo is starting to get populated. Okay, so the tutorials, the lectures, the reading. Also, there's an exam, not this year, but past exam that I put it up so that you're aware of. You can see here on the tab here. Okay, just you're only going to see the 3 here. So the past exam, you can put it up. One of them. Usually my exam are relatively similar. Okay, so usually the essay, writings, and talk about design. So therefore, don't ask me for the solutions, for the answer, because essentially most answer will be similar. But there's no, as I said before, in the design, I rather don't have a one set of fixed solution. It's not a mathematics, it's not a programming. So there's a many way to go to get it the right answer. Okay, so therefore, just try to understand the question. This is to give you the ideas. Okay, that's why I said yesterday is about the exam, the listen to lecture. That's usually how I interact and students will learn from it. Otherwise, you end up with copy. The exam is going to be one A4 note, 2 sides that you can write on, that you can bring into exam. Okay. However, if you don't quite understand the topic, most likely you'll be copy the message that I wrote it on the slide. And that's very easy for me to tell that you didn't actually look beyond the slides, what I'm talking about. So therefore, that will be, you won't get the super high mark. You will get pass mark, but it's not going to be a super high marks. Okay. So that's just give you some idea. Just have a look. Okay. So I'm just wondering, it's how many capacity is this one? It's about 15. Really, this one really fit 85. It's look a little bit smaller. It's definitely smaller than yesterday's room, but yeah. Although it does help that only a fraction of you turn up, so it doesn't make the room too crowded. All right, so yeah. So please don't ask me about the exam yet. I haven't finished the exam question yet. I'm trying to survive this week, so just give me some break. But the exam are mostly. That's why I never really go into the answer precisely. This is what I'm looking for, because it's just one of the solution, one of the options to go there. So it means you could have a different answer. But there's many obvious ways to go wrong with it. Okay, ask question you didn't answer the point that I asked, or you give the answer the justification that weak. Okay, you can ask me if this is a good justification, is this a bad, a strong justification. You can gauge my response, and that's perfectly fine. But don't ask me about how to answer this one, how to address these questions, whether I change anything. Try to be more specific on the questions. Okay. Yeah, the exam coming quick. Yeah, it's 2 weeks from this Friday. Okay. It's a 2-hour exam. Okay, so 1 note, so you can take in. Okay. So the lecture now, I start to add a little bit of it's in session. Yesterday I forgot to put in a reading, so I have a subfolder within the day. You can see the PDF. You can have a quick look. Okay, this is usually a good idea, but it's not. Let's be specific, because the reading here sometimes could be very technical. I could throw in some high citation paper. Okay, that it could be a high impact for those who actually want to look beyond the unit, but it's not necessarily for you to understand all the technical components. If you just even if you aim for HD, okay, because some of the paper will be beyond this class, okay. So what that means is that this is just to give you a background of understanding, because from my lecture, you probably gauge the start of my lecture, a lot of photo, a lot of video, a bit of notes. So there's really and we have no textbook in this one. So therefore, what are you understanding? Even though you're going to be on recording, listen to my voice, you can listen to me 10 times talking about the same thing, but your understanding won't go beyond that. So all this reading will help you form those parts. So this is more or less a little bit of a postgraduate study. Okay. So try to read them as you try to gain more knowledge. Okay. All right. So another thing that is actually now online is a lecture recording. Okay. So if you want to listen to my voice 1 to 2 times, so this is where you can go. You can see here that you go. So you have to log in with the UTAS. So anyone done this before? You used this recording before, I assume? So this is all our future. So right now it's recording. It's our session now. Huh? Sorry?
The link on Milo didn't work.
Oh, it didn't go there?
Yeah, as in it just comes up with like error.
Oh. Okay, so maybe I forgot something then. I'll have a quick look on this. I think it's about access, but I think it should be automatic like Milo, but I'll double check that. Okay. All right, so that's one thing I need to fix. So essentially here it's just like this, but you never really get to this far, right? Yeah. Did you? Did you get to this far? Oh, and then when you click the open, then it's just blank. Yeah, okay. Yeah, I think I had this happen to me before. Okay. But anyhow, once you successfully, you will see some of these. Yes. So the recording will be essentially so it'll be like this. Why it's not running? Oh, it's at the bottom. Yes, so that's, oh no, that's, yeah, that's this one. Yeah, so this is from yesterday. Okay. So you will get some of this, has a slide and has the audio on top of it. Okay. So I'll double check the access code. All right, so.
Does that show up in real time? Review this live?
Oh, no. This was the pre-processing. So usually after about a couple hours after the lecture, I'll get an email come from the system to tell me the recording is ready. Then that's when I know it's available online. Last night I just need to link them to the Milo, but I think I have to look over the access thing. All right, so that means unit is getting more, as I said before, this week is about trying to get everything up online. So you get a sense of it. That the tutorial components start to popping up now. Okay, so you can get a sense of that. Any questions so far on the Milo? Okay, so it should be relatively okay. Let me check the groups just quickly. Yes, so we have a practically full set. Yes, there's not much room there. So as I said before, if you want to swap, it's perfectly fine for the material size, but you should best to find one to swap with you from the between session. Otherwise, you're going to be creating, we already jam. Okay, so just to create it, you don't want to end up with 40. Yeah, right now it looks like 30 of 30, which is about maximum. In fact, the maximum is about 20, so we already went past that only. So your prox card, everyone has prox card that get into the building, get into the lab. I think you should be all enabled for the lab. So we can test it out at 11. So well, today anyways, if you have no access, then you have to go either tell me to tutor or other tutor, or you tell Chris Burton, which is the admin at the front office on the 3rd floor. Yes, I think right now they kind of, so somewhere it's good for our class because we already have 85 students going to the one lab. So I think that access card will allow you to have full access to the lab, okay, even though it's still a little bit small. All right, so good. I think we have to finish. Yesterday we have a bit of a few slides left. Okay. All right, so this one we kind of stopped yesterday. Okay, so some slide here. So basically, this unit is really understanding. Okay, you might actually wonder why we're talking about human, the device, VR, and everything, but why we keep talking about humans, what the human behavior look like. This is a lot in some way. This is what HCI is born of, human-computer interaction field. It's actually multidisciplinary. So some of these would be psychology people, some of these would be engineering students, some of these would be a computer science student, some of these would be a social science to study how humans behave inside this new interface medium. So there's a lot of few things. That's why these units are packed. It's kind of built, the way I designed it, so it's built so that non-technical people can come in. Okay, so that means some part of the student of 508 would be a very good fit into this way. But you do need to exercise the other part that if you're less technical, you should bring more on critical design thinkings into that kind of thing, what the design good for. You should be kind of compensate for that so that it doesn't look like you don't have anything to offer to the unit. So this one is just give you a balance. So that means the HD here could be come from the technical aspect of the drive, or it could come from the design component of it. Okay, but essentially, assignment 1 would give you an idea how you view them. Okay, or at least how I mark them. You would tell that how much I grade your input so far. So this one, I think I touched quickly on it. Record experience. Okay, so this one is just a simple how you interact with it. So this kind is basically there's no live interaction. Okay, you just observe. So this is like a movie, you're watching a movie. Okay, so now another one is actually a live one. Okay, you can see. Essentially, it's a live view inside the military tanks. Okay, so this one is allowed. You're actually looking to some kind of transmitter. Okay, so some kind of medium that you actually see through them, but it's actually happening live. Okay, so of course the task would be live. You don't want to see danger coming 2 minutes later. Okay, so that would be bad for this kind of operation. So and then of course in medical, you would have seen some of these. Have you heard of what they call Da Vinci? Okay, Da Vinci. You were, not Da Vinci Code, the movie, not the artist, not the innovators 500 years ago. Da Vinci is one of those surgical operators, a very expensive robot arms, kind of big version of this thing. But the guy would just kind of look into the surgeon, and they have about, I think, 8 to 10 mechanical precision arms. Okay, so those are kind of coming online now in one form or the others. Okay, of course, when you start off with in the past, people tend to dream something ideal. Okay, this is a link to, like yesterday I told you before, the big current what we are on is a recent wave of the VR surge into the market, but it's the last wave that happened. It's 20 years ago, around mid-90s. So that's centered around the lab, the HIT lab in the US, which is allowed to do virtual reality. At that time, project would look very green. Green means very blue sky, one very futuristic. Okay, even though the technologies are quite limited. So something you will look something like this. Which is actually, you can see some of these advanced, actually is some of these items, you can try to think here, is actually today is still not there. But some of the technology, especially the headset and the processing power, graphic card, rendering ability, it has far passed beyond those 20 years ago. And that's what makes the current wave coming through. So which is that. And the key part for this one is the field of view. Okay? The field of view is actually there are two things that the current VR headset do well. It's the field of view and the tracking, accuracy of tracking, and responsiveness of tracking. At that time, the tracking, but first of all, you understand the term tracking? Tracking is if you put a mini screen in front of you, if you don't track the way your head is moving, you will see a static screen moving with your head. Am I right? So you will just see what they technically call head-up display. It's something to pop up and then it kind of stick there, or it doesn't interact with the head movement. So tracking is always used in our field. It's basically tracking the movements to create illusion the object is actually there. You actually have to track how your head is moving at all times. So the reverse graphic that display to you will be proportionally geometrically correct. So that means it appear to be, if you tilt your head, it appear to be tilt in a counter direction. So it appear to be static on the space. So the tracking at that time is more or less like 10 frames, 20 frames per second. Okay, and the tracking is expensive. One system tracking alone could cost you $50,000 US, and that is actually with a bunch of wires, everything. And so it becomes sort of geeky like kind of setup. But nowadays with Oculus, you're going to see is about 90 frames per second. So what that means is that it's extremely quick. Okay, so I mean you will feel subtle movement is good. Yeah, but that's when, if you push the wrong way by moving really fast inside the VR, you might get a little bit of a sickness, because essentially here is still, it's going to be down to the conflict between what you see through the VR goggle and what you feel inside the inner ear inertial sensing inside your brain. Okay, so I mean, just try not, and of course you have a cable still, you probably don't want to move too fast anyway. Okay, so in this case here, the advanced feature in this set. Okay, so actually, believe it or not, the whole thing here is driving this thing. Okay, so essentially at that time, it's only a few companies There's quite no, at that time it was SGI, I think, yes, so which is, disappear. So, and you can see all computer driving. The one that actually is intriguing that still I think is slowly making way back is a glove. Okay. Used to call data glove, so you can touch on it. I think a lot of, due to the last recent year of advanced image processing, gesture recognition, you would have seen some natural gesture wavings magically. The leaf motion, I think you might have seen some small device that allow you to move your hands around. Okay, so that does come in place, but that is nothing, but it doesn't give you a tactile. Okay, tactile feedback, so you don't feel vibrations or anything, so you just wave. So this is the ideal, but the setup of this is actually costly. Okay. So this is some of those, but this is give idea, even 20 years ago, give people idea that actually this could be good, but it's just not all the ingredients are in place for the VR to really take off. But hopefully now is actually the time. And it actually nowadays is actually the simulation components is beyond what the visual. VR mostly visual, audio, okay? But this is a tactile, what I was talking about, a tangible user interface. This person here is called human medicine. Okay, it's used commonly in a training for nurse, doctor. Okay, I think this guy called Simman. Okay, he's operate on 4G bandwidth, so he's a wireless. So that means he can control from controller, which it could be sitting, observing from distance. Could be a trainer. Okay, they can activate from remotely how this guy will act. Of course, he won't stand up and walking. He practically made to be on the bed only. However, he does have a pulse. He does have, and some of the advanced model can vomit, turn red face, and you can have, and you can inject the needle in there. So this is really about getting people to familiar with what they're about to see. Usually they find it useful in the first year entry. Before you enter into a real patient, you might want to kind of prepare them for it, not just procedure-based, but in terms of psychology-based. Okay, in terms of what they feel like, because some of these could interact it. They use it for some of the testing, okay, exam. For example, if you inject something and then something happens, the body, the patient reacts a certain way, okay, and how would they react to it? Of course, you don't want to do this with the real patients, so this one would be a kind of alternative. However, the issue for all these simulations is always about compliance and about how much can you really trust this thing. I'll talk about that later on. It's a simulation, make it happen is one thing, which is mostly is about this week, how people make things happen. But then, how far can that go? Okay, I can talk about my project a little bit there. Ability to trust. For example, real-world example, for example, when in the 80s, 1980s, there was a big boom in neural net. Okay, you would have heard of it in deep learning at this time. Neural net would boom then, but it kind of stopped because it didn't quite take off the way people hope, because they start to tackle the problem that harder than what they can afford. For example, they can try to set up a fly airplane without a pilot. Yeah, the scientists, computer science people will believe that it's possible, but airliners don't want to take a risk. And you probably, we as a passenger probably don't want to take a risk either, that neural is driving your, flying your airplane. So some of those will come into play. Simulation is one thing, but getting the outcome of the simulation is good. So far I can tell you the simulation is very good, acceptable, except all other domain in the area of procedure-based training. Training, whether you remember the procedure, not remember procedure, testing your different very rare cases, like this one could suddenly inject 10 hours, 100 times, you might actually don't get any reaction, but what happens if they get reaction? So these kind of simulations are very quite good. So some of these, the next few slides here, about the project that we've done. This is our first example I'm trying to link to how you merge between the technology and the design components. What the term that I use in my assignment one, what is user need. Okay. So this is a project, this is my first project I got here. I did with Cyro, called Magic Map. So this is just to go through some of the story. So this is some of the maps. So this is Tasmania. Cyro here is a research institute here. I think they're in Hobart. The branch is in Hobart here. So what they do here is that they have this capacity to put sensor environment, temperature sensor up all around the center state to monitor national resources. Okay, the stream, the water stream, the sun temperature, things like that. The problem for them, they call sensor web then. It's a two-way web base. Okay. So I'm not sure you can see that a little bit smaller. So you can click. So this is a screen capture of what their web look like. So you can see it there. These are data scientists. They go through different sites. They click on it, and then it depends on what side they click. Different sensor will show up. Okay, and you can see they'll start to show. It's basically the same interface with Google Map. Essentially, it's laid on a Google Map thing. Okay. You probably can't see well, but essentially that will go to a different type of sensor, or whatever they want to do. Then they approach us, I think it's in late 2011, and say that they want to explore a bit of a kind of interesting project to try to keep people engaged, because they realize that people, when they put this up, available for free, available to public, they realize that the people that use them are themselves. There's nobody really actually using the system per se. So they just try to explore what other thing. At that time, AR was still very new, relatively new to outside AR people, AIA's community. Okay. So in that case here is that. So in that case here, with the large data sets here, this is simply the problem. These are too cumbersome. People come to the website, they don't really have engagement. I'm not suggesting that what solution I'm proposing, the project we end up doing for them is really helping, because it's 2012, so if it's really that helping, it'd probably be alive now. But it's just simply a research project, but it's a good example to show you how to merge some of these concepts together. So, okay, so we have a problem statement, okay? The current statement, so there's something like this, is too cumbersome, is too many clicks and things like that. So that is one thing. When you are interface design, you will gather this factor. So when you read about review of the paper or any application, you have to find what actually the difficulty of the current practice before that technology introduced. Okay, that's what it's called. Then, so the next thing is that this is the effects of that, in effects in attracting general publics. Okay, so that's what we kind of form at the beginning. Okay, this is why we not necessarily know what technology we're going to be using, but we understand the problem. This is what you usually call problem domains. So you try to understand what are exactly the current problem, current inefficiency, current bottlenecks, and then difficulties. So this is some of this that you can see here in the scale. This would be considered very light. Light meaning it still works. It's no problem there. People still, if you really want info, you can still get from them. But it's kind of just want to see whether they can have a niche market they can push up a little bit further. And that's kind of perfect for us. Okay. So our project goal is to develop a suitable human-computer interface, okay, which that attract non-expert users to engage and understand the sensor data web. Okay. So this is the same thing here in your assignment 2 and 3. That's what you actually have to define what the problem is in the beginning. And what is your goal of interface? Because you're not actually, if they have a problem with sensor, for example, sensor doesn't work, of course, your interface has nothing to do with solving the sensor problem. So therefore, it's more like the big space here, if you go back here. I try to use this as show you the case so that you have a clear understanding of what 82 and 83 will look like. In fact, 81 that you're doing now is the front end of those 82 and 83. Because essentially here, understand the problem that you're dealing with is a key. Okay. So engage and understand. So you define those. So that's a problem. You scope it down within the area. Okay, this is the area in which you actually about to make solutions, suggestions, and make progress. Okay, as you can see here, engage and understanding is one of those. Try to address the early problem that we identify. Of course, there are other problem too. The sensor is not always online. That's one thing though. There's a problem. It is sometimes we build a system that actually live talking to them within a 5-minute update late. But the problem is that their sensor most of the time doesn't work. So that means you have problem with communication channel. In the end, I think we did the offline unit as a backup. So, okay, so now you define a goal of the design. And you can see here the goal that you design here. In this context of the context of this unit, it should be centered around interface. how people interacting with. So you have to make your judgment what to do. Don't make it sound like, oh, we need to improve this internet speed. Like, of course, yes, you need to improve speed, but nothing to do with your interface, right? Unless you actually make the interface to compensate for the slow speed. Okay, so those kind of things. But you can always check with me if that's questions. So our approach is very three-step. Okay, so we want to create this. Okay, so this is a step. Within a few days here, I will lay out some of the design steps so they get you ready for your assignment 2 and 3. Okay, but essentially kind of follow this step. So this example just give you a kind of bedrock for something that you can come back to. Okay, so first is unique experience. So as you can see here, I haven't talked about AR or any technology yet at this stage. From the problem from a couple of slides ago, define the aim, define out what should be our approach. So intuitive interface. Okay, even though this term I use it for my convenience, but in fact this is the hardest one to do. Intuitive because it's subjective. Okay, so intuitive to whom? Maybe to you it makes sense, but when you hand it to other people, it might not be intuitive. So defining this, just like what Tom Furness was saying in this grand challenge, what is a metric to measure those where we're doing the right track? Okay, so I think those are kind of open questions. And then visualize them. This is more or less a little bit technical, addressing the problem that they have. They have many sensors, they have many clicks, so we try to optimize those to be a very more simple to use. Okay. So the key technology we end up doing. So this you pick the technology. So this is in Newnham in our campus in front of our lab. So you can see the mock-up of our AR interface to have AR posting, and you will see the avatar kind of floating here. So at that time, of course, the iPhone and everything is not that powerful, so we'll go with our most powerful mobile platform, which is tablet then. And you have a sense of TUI, so this one, it just try to get the sense of a click. So in this case here, I think this is just example of what you will see some of this video later in the next few days. So this is about tangible, you interact with space. So in this case here, it's a kid is using a brush that look like they're painting on something, but in fact the brush at the center has a camera. Okay, it recognizes the color in which this device are painting to, and therefore it's changing the color of the object on the screen. Okay, so that become give you the sense of this interaction, just like the prime example that everyone uses nowadays in the TUI component is a mouse. It's a mouse, your mouse. Basically, you can touch them. You have a tangible feedback and those kind of things. Okay. So essentially, here we create what we call magic maps. So let me see. Okay, so this is a map, and those are augmented reality sensor, the readout from sensor. So and this is some instruction. This is a capture from the live stream of the webcam. Okay. Nowadays you can do this on mobile device. So. And that's a tangible component. It's just a little turntable dial. Okay, it's a physical one. There's no electric. There's no IoT or sensor or anything. It just has the little marker on top of it. And what it does is that actually the camera recognizes how it's moved based on the pattern it's moving. The actual the black square with the symbol in the middle. That is technically called we call fiducial, or you call marker. Okay, that's what allows computer vision, which is through the camera you see here, to detect the orientation change. But what is changing from the map here, as you can see the word tracking I explained at the beginning, this is what you're doing now every single frame. Because otherwise that would not appear to be stabilized on space, because you are moving through space. Okay. So that one you can see here. So it's try to change the time. Okay, so that's a 12-hour, 24-hour clock. So changing what the wind speeds will look like to a different site. Okay. We used copper library at that time. Okay, but nowadays you can blow apart this quite relatively quickly. Yeah. All right, so that's hopefully give you the idea. Let me emphasize on some of these. So this is for the benefit of you. I thought you again. It basically, you just have to look for the problem first. Okay, so mainly is more this slide. Okay, and you define the goal that actually relevant in this context, and you go about what you'll be the different approach that you want to do, and then you come up with some key technology. Okay, so in your case, we'll go some of these. So that means a good report. If you're looking for HD, you will really go to this step with some good details. Okay, so in-depth details. Okay. This is for presentation, so oftentimes there's no text involved. So that's what getting to. So it start from the web all the way then it appear. Okay. So this is a whole small project. We did this in 2 months' time, so 2 or 3 months with me and my help from the developer, one of our former students. So we developed this in 2 months' time or so. So that means the actual design would just try to get it done. Okay, so it's not really actually have a full mode, because one thing missing from all this design is actually the tail end of it, which is a usability. Okay, so usability, which we'll cover in the lecture later on. So we said when you build something up, you practically have to basically have a mechanic in which to test whether how effective they are. All right, any questions? Let's just wrap those one up. Now we're moving to our slide, but on this one. These slides are on Milo. All right, so this one is about virtual interface. Okay, so now we understand, okay, there was a bit of issues in user interface, what that means. So this is about virtual interface, what that means. Okay. So this one is revisit from yesterday. Okay, so this is understand, remember the diagram, the human on the left-hand side. So this is trying to understand what humans look like. As I said before, we have not evolved as fast as a machine that we built. So machines are built quite quickly, but we are no different than, 3,000 years ago, I believe. So it's just experience are changing. Okay, so this is what current interface will look like. Okay, so we can go one by one here. First one is actually doesn't take advantage of human being 3D spatial being. So that means we sense everything in 3D. Okay, everything pen a drop or someone make a noise, some phone pop up, ring, forgot put on mute. Then we can practically tell which direction it roughly come from. But interface here, what you get, notification, which you practically pop up your phone and okay, there's something happened. All right, so this is it's not per se is a problem with the past. With the current, the past technology, that's what it renders. So therefore, what it does affect you is that it forces you to learn how the computer speak, not the computer learn how you speak. Okay, so that's the difference. And second one, the field of views. Okay, this is as I said before, the human has roughly, in the layman term, has 2 visual systems. Okay, we not actually have 2, or we have 2 eyes, but it's not really one eye, one system. The one eye, basically, the 2 system is a core. When I focus it on, the one is actually if someone walking on my side, I'm aware of something happening on the side. So it's a kind of central core of your attention, and then peripheral. Okay. So most of the display allows you to do it in the center, when in fact you have ability that built into the human that you have ability to actually you can read visual cue that come from the sides. Okay. So that's what military use a lot because they want to expand their bandwidth quite significantly. So their pilot in the critical moment they have a few seconds to design. So that means a lot of things that can help. They have to bring it all. Okay. So this is most of the time. So you end up with something smaller and. But your phone is getting bigger, so it'll get a bit more, but it's still, you're practically looking at one piece of the device. Okay. So this one is just like the image I showed you yesterday when people were just looking at the monitor, okay, from the 80s. So this is what they call outside looking in. So just like this, I'm outside, I'm looking inside the system. So this will be a window portal to whatever else that connected to the computer. But essentially, you put your attention here. So this laptop, the good thing is that this portal can be anywhere, right? The one that's missing is that you're still outside looking in, because essentially here, advantage is you can put this anywhere, but at the same time here, why you put it here? What you make use of this part of the world. So essentially, you're kind of disconnected, because you're actually zooming inside. So you're missing part of the reality where you are. That's why if you play a mobile device a lot, then of course, probably there's a good example. If you have younger generation, probably kids, children, and then they would really know each other or not live together, so they met each other some family function for a few times a year. You will notice that nowadays you can put them in a kids' table, but they don't talk. They actually chat toward their app chat. So they chat to the one that they sit next to them, the opposite them. I think you will see this more and more in common. You probably same thing happening to us now. Is that if you sit there, you probably don't have any meaningful thing to talk, then you can go like that. And then you can take a picture of that. It's oftentimes it looks like that. It becomes the barrier that I think a lot of social science are now looking into this space, whether it's actually technology, what's the side effects of the technology. Okay? It makes you faster, but then it's less appreciated of what actually in front of you. Mm-hmm. So, this one is very difficult. Okay, it's still computer-like. So, for example, this is what engineer versus designers are like. Okay, engineers, and most of you don't have engineer background. I have a degree in all engineer. So, engineer is about building, fixing. A lot of time fixing, building, getting somewhere to make it work. Okay, the design is less important. So that's what an engineer like me in the past build you a thick manual for you to read, like Unix manual. If you're programming, you will see a lot of, which all makes sense from the engineer point of view. But that's what is actually computer-like, is like the way the engineer build like. Okay, but it's not that intuitive for most users. As I mentioned yesterday, the paradigm is shifting to it. Because now you can see all the code available and all the sources. You can go to Unity website now, it become expansive, huge. Okay, so they put more emphasis on that. So hopefully these would changing over time, but you still have to learn quite a significant. Okay, that's why I think I mentioned Google Home and Alexa, and those are the medium of interacting with computer will changing the way we interact. Okay, and then add with a lot of artificial, some of the AI, artificial intelligence, that would help make a lot of interaction. Interaction idea in my case, even though I said this 10 years ago when I come here, it's still doesn't exist now. It's actually computer should learn what you need to do instead of you learn what you need to do. So it should learn. So for example, if you come in with a little bit of less knowledge or less skill in that space, they should know, try to detect and try to get you to use the system instead of try to get you to learn whatever step. Right now is better, but you still need to learn all these steps, including our tutorial this afternoon. You still need to learn all those, when in fact the system should get moving the other way, okay? When they actually try to learn how much you actually have, and then try to get you customized learning for you to come along. So in the future, in the tutorial, you probably walk in, put some device on, and you'll be talking to a virtual tutor, and they'll be kind of try to be customized what the learning curve for you. But we are not there yet, so this is a whole purpose of this virtual interface. Okay, so this is try to overcome what the current computer interface. Okay, this is a lot of things are changing now. There's a lot of push in the hardware at the moment, VR headset, AR headset. However, this design, which is the focus of this, more or less try to hope to get a lot of students in this class to think about, is really still haven't shipped too much. Okay, so it's still more or less cool thing is show new device, but whether the way you use, it could be the same way that you use. So it doesn't really matter now, because now I think most of the money go into those building the device. Okay. So what that means is that we are really practically focused on this part. Okay, the more understand on the human side, the more is a problem domain. For example, in those sensor web example, it's about understand what the world, how the current things work. World doesn't always mean real world. It could mean the application that's currently working. So you could be act as an intermediate in that step. Okay. So this is purpose of the virtual interface. This is just to set up, because the rest of this unit is really about virtual interface. Okay. Virtual interface here is not physical button. Okay. So this is about the conceptualized design. Okay. So this is about how to overcome those human ability coupling issue that Tom Furness talked in his paper that I just uploaded last night. You could see that and read through them. So the idea is that human has more capacity, but the system is unable to allow them to access it. Okay, so therefore a lot of them are really just kind of wasted. Okay, our capacity. So in this case, the human sensory perceptual is not it's not utilized fully in the interface. So therefore, the point of this is that you have 2 points that mismatch. It's a simple idea: the human capacity and the computer interface capacity. The one that you adjust, that you can have ability to adjust, is not really human, because human should really the way we're born is practically more or less static, and it's not really able to change too much. But therefore, the easiest one is a virtual interface. So you design the interface to take care of those, to make these transitions the best you can. So, and this will satisfy the goal too. So, the same thing with the apps now. I think I talk about iPad, the way in changing from the mouse and keyboard to a touch screen. That changed a lot in terms of human capacity. The elderly, as I mentioned yesterday, have ability to actually access those easier without learning too much. So this is a quick example. Okay. Now, the term virtual interface here, so essentially technically is that add input, output together. Okay, it basically take input from whatever the sensor and the user give them. Output is display, usually sound and something, vibration, send it to back to basically complete the interface loop. Okay, so this is a technology. So information is transmit to the sense in the form of three-dimensional virtual contents. So this tangible image 3D contents, okay, which we'll explore in tutorial. And then you have this behavior of the user. Okay, we won't cover in psychology. I'm not a psychologist, so this part is extremely delicate. Okay, so when you introduce certain new device, basically you want to run a usability test. Sometimes this issue come up, whether it's ethical, whether it's actually safe for people to do it, and these are the kind of things. So this is related to that. But when you design them, in this unit, it's since you're not doing any real experiments, so it's okay to think about. It's probably best if you want to have a high mark in the unit, you need to address some of those. Our human has this tendency. Okay, so therefore interface should avoid, the design interface should avoid those kind of tendency. So this is just to provide a background, so what the stage for the virtual interface. So hopefully you get some idea. Okay. And in the next couple of slides here, I'll really talk about some terms. Okay. Transduce, so technical term, you just read a little bit out. Sense and human model function, what that means. So some of these is an old technical term, old-fashioned, but it's kind of useful to have, to learn a little bit of that. Okay, so the next one is perception, cognition. So some of these, as you can see, all this is really about in your head now, okay, how you perceive them, okay, why people like apps, one app, and some people doesn't like that app. So those kind of really about perception, and also 3D perception, that's also part of it. Okay, you know, we all observe things in 3D, but when you look through the screen, it practically down reprojection into a 2D screen. So there's a lot of information lost in that transition. Okay. But there's a cool feature that came up from new iPhone. Have you seen that, the 3D picture? Yeah, I think you have seen that. So essentially you take a photo, but it has a bit of a clever technique to actually define the foreground. So basically when you render it back, post on Facebook, it will look like you look at the screen, but then you actually can move your phone, and basically you can see that person of the foreground that actually stay in there, and then the background is moving slightly. So it gives you be kind of a pseudo 3D component, but it's as you can see, the whole economy here is about driving to the snap and choose and easy to use and that kind of thing. But the technology backend actually moving quite a bit to make that happen. Mm-hmm. So cognition here, as I said before, we have mental models that we expected. Okay, so that means if you're dealing with the design, then you have to understand how people are working. Well, let's say this is the way they work for many years, and you're about to change, revise, and affect the way they work. Then you have to understand a little bit of how they understand the process, inside the process. So this is typically the most difficult part, okay? At least from the industrial project point of view, okay? Because this you have to understand. For example, currently I'm designing a project for a company in Tasmania. But they have a workflow that's quite engineering solid for 50 years. So we need to introduce some technology that's changing and improve the way they work, okay, in particular domains. So this is extremely a delicate component. But once you put the two of these together, okay, so as I said before, what we're talking about here, human computer, essentially here you have one size. It's a technology side. So in this case, it's like all the cool devices that you will find on the internet. So this is really just about what it is, what sensor they are, things like that, what it can do, sensor connect, different type of sensor, device and headset. And the experience side, okay. This one, experience, it could be a functional use, it could be other things on this side. Essentially, it's really about how you plan to use them, okay. So this is really from what it is, which is a bunch of sensor, a bunch of firmware, everything to connect it together. But this is changed to what it does really do. Right? For example, if you put example again on the mouse, Mouse essentially is a control optical sensing of how you move on the surface. You can talk now a lot. Engineer can talk about what sensor inside a mouse, okay, inside a mouse. And then, but the thing is, what can you do with it? What it does? Okay, it moves. It's become part of the component you interface with the graphical user interface on your computer, and that's the functional use, and that's the experience side of it. Okay, so that's become a two sides. Okay, so this is a changing. Evolving from the diagram, we have humans and computer. This one is actually have two clear sides. Okay, it's going to leading into a design that actually you have, when you consider them, there'll be a two-sided requirements. Okay, which is one is really about technology, and one is really about what it's for, what it's used for. This oftentimes connect to computer, not computer, sorry, connect to the human. Okay, and the task itself. Okay. Which is the task is imply that you actually need to have a human to perform it. Of course, all this is actually, you create a new affordance inside the virtual environments. And so in this case, it's actually the interface. Okay, so this is where you try to marry between the both of them, try to find a balance between both of them, that actually what it is it would do what it's supposed to do. Okay. So that's why the example in the magic map was setting a goal and derive into the approach and then solution. So that is about building this purple bridge. Okay. So you can see here, this is a conceptual context shift. Okay, so this is really about application. So one interface in our areas is oftentimes there's no one solution for all. So oftentimes you have to apply them into different fields. For example, AR would never. AR, that good AR apps that actually work on one thing may not necessarily work on the other. So therefore, oftentimes people see a Pokemon Go and think, oh, that one could be applied this directly. But actually, if you pass to this unit, you will realize actually shipping between the different domains require a rethink and redesign component. Okay, because essentially you affect the whole right-hand side here. So this is just we touched on the slide yesterday. So the three components. Okay, so hardware, software to run them, done the device, and the design, which is actually come from the creative thinking and the way you analyze the task and the bridge between the task and the actual technology itself. Okay, and that become part of the design. So essentially, the design is actually the purple bridge here. Right, the hardware is the technology side. Yeah, yes. So the bridge here is that purple one. Okay, so. All right, so let me see. I have two small slides, and we'll take a quick break. And this is our generic approach of the paradigm. This one has been done for at least 20 years now, but I think it's still very valid. On the top left here, GUI. GUI, so that's a GUI, graphical user interface. So that came up in the late 80s, early 90s. Windows and Macintosh 2, mouse, and those come in that period. So that would mean a human in blue. The C here is a computer, okay? So and the R is the real world. They're sitting really separately. Okay? Just like the laptop here sit on the table, which has no relevance to the content of the computer. So you practically have a clear divide gap. Okay, so as I mentioned, using my laptop example, they can be anywhere. Okay, so it doesn't have to be here. It's not connected. And the one that we're going to be covering in the second half of the lecture today is a VR, the virtual reality. That's when you actually move the human in blue inside the computer contents. That you're actually sitting in them. You're not actually sitting on a laptop, but you're sitting in a content that's driving your computer. So essentially, you are immersed inside the contents. So that's why you're in the little yellow box computer. But then the key part here is that you disconnect it, okay, from the real world. And this afternoon you will feel that. Okay, so and then once you wear the headset, you realize actually people start laughing at you, and you don't know what the reason is. But anyhow, I think it will be your turn too. Yes, sir. So essentially here you disconnect it. Okay, so you don't see anything. But the idea here is that you immerse yourself in there. This is where a lot of people didn't quite know what to do. Okay, you're inside it. What I'm supposed to do inside this? So that's when the design component is really the key. Yeah, because putting a head on, you will see all kind of examples from Oculus, for example. They have all App Store, they have everything. So you can see examples, showcase some of those. So you see plenty of those. But then before it be available there, what's their goal, what they were trying to do. And that is really the key component. This one is also the next one we will cover, augmented reality. Okay, so that one is actually the diagram show that you actually now go back inside the real world, the R in the big box here, real world. So you sit inside the real world, but you look through a computer-generated layer. So in this case, you look through some kind of screen, head glasses, and smart glass, see through them, and go to the real world. And the real world here is come to the glass as well. So that is how you actually interacting with it. You see overlay of AR, so you will see some of this example. Okay. Once you put a HoloLens headset on, you will get the feel for it. Okay, what is that? So basically, you can look through here. I can have an object content floating in midair, and you have a HoloLens. You can actually see it's floating. And I move that content, you will see the content moving around in space. Of course, the technology at this point is still limited to the headset. So I mean, those who will see in that space need to have the app load into their compatible device. Okay. And this one is actually, this is what now evolved into IoT. Okay, so ubiquitous, it used to be ubiquitous computing. Okay, but essentially now, I think we all know as IoT, Internet of Things. So okay, so that is actually another paradigm. It's still, compared to the interface already, VR device has gone further and the most advanced. Okay, and now a lot of people are working on what to use it for. AR is slightly behind, okay, because technology is a bit more difficult. But it's still coming out now. You will see HoloLens is a good example. It started coming out, but it's not quite there. Okay, it's still, people are still working out some technical challenge. But IoT here is still really much behind. They're still in the technology phase, how to get all these sensors to working together, let alone how people interact with all these sensors that will be hiding around you. Okay, you already experienced some of that with the smartwatch and everything, but that is just a glimpse of what is might come. Okay, so in that case, you already turn the smartwatch to look at what notifications look like, how to design those to work with inside you to improve your efficiency is become the next step. So this one is really going to be what the future might look like. So the computing in the future might not be necessarily inside your laptop. It could be inside an earpiece or inside of things that you can be touched on the screen here and you could see things and things like that. So there's quite a bit of what future might come in this space. So hopefully you get the idea. So this is our basic diagram. Okay, so what the real world, so put that into our visual context. So on the real world is on the far left. This one is a virtual environment, completely immersive, okay, completely virtual. And you have augmented reality, where the real world and the virtual contents are mixed. So in this case, the virtual content is a little cartoon 3D animation of the samurai. Okay, so that's a virtual. This look to another set of AR camera, so you can see this. So you can see the rest of it are real people. Yep. And then you have this one. This one hasn't really populated too much. Okay, augmented virtuality. So this one is actually you inside the virtual environments, but you actually project the real world inside that. You will see in HoloLens there's an application like that. It's basically you can have a Skype people put it on the screen and you can move the Skype instead of it on the screen. You can put the screen of Skype everywhere. So that is a little bit harder to do. Okay, so but it's essentially this is a spectrum in which people tend to look. Some of the people, that's why the name of the unit doesn't use the virtual and augmented reality, because sometimes you could wander into this space as well. Okay, so some of these, so this in somewhere from real and virtual, somewhere in the middle, it's called mixed reality, depending on where you slide things. AR is just a subset of those mixed reality. Mm-hmm. All right, so any questions? Yes, so, all right, so let's say we get come back at 10:10, okay, 7 minutes. Yeah, that you mean the haptics in the market now?
There is, for example, what if you were to wear a haptic feedback suit and have a massage or something that had any actual interface or data visuals? Or,
Oh, you mean you're talking about sun per se? Or okay.
or even, or,
Actually, that would consider an interface in general.
and so, but which predefined level that kind of augmented reality, virtual reality, what kind of
Oh, okay. What is classified? It will classify some of those who go into what they call TUI, so tangible user interface. They will be part of those. But that's why the tangible, as I mentioned yesterday, is very hard for us to do. We don't really have the gear to do that. You actually would require you to build some custom sensor, tie something, things like that. I think we just don't have the bandwidth to do it. Yeah. So TUI is born out engineering. Yeah. But TUI now start to mix with TUI. Actually, TUI is a result of the engineering plus the design, because they got to know what the interface will look like before they do things. MIT do a lot of these things, so I show a nice slide somewhere. But it's not a I mean, it's a visual stimuli, it's somewhat tangible. The key part is that you actually touch them.
So, I know a guy called Dr. Jordan Union. I'm not sure if you know him. He's a biomedical engineer, and he's been he dabbles in a lot of different technologies. And artificial limbs and a wheelchair that can all be controlled if they just.
Oh, he's from MIT?
I think so, yeah.
He's the one that had amputated himself. He also amputated.
There was one where I think when he was very young.
Yeah. I listened to his talk before. Yeah. I can't remember his name. Yeah. He has he's had a double amputee himself.
So would that be considered?
Yeah, that's an interface. Yes. But that is actually beyond what we have here. It's basically either brain or sensor nerve interface. So essentially here you're interacting because his artificial limb need to somehow work with the sensor, with what the missing part is.
So without the graphical user interface,
Yeah, that's right. So that is actually would sit inside what they call this brain user interface, brain computing interface, BCI.
because you're still digitizing, like you're still, and you're simulating an environment, but the environment is something virtual.
That is actually it's in a similar spectrum with TUI, but their interface is actually much harder problem. Because they deal with biology, they deal with mostly patient with some amputees and things like that. So they're quite challenging, and that would lead to if you've seen some work about contact lens AR, I mean those are actually going to bioengineering.
Biometrics and
So biometric is not as bad. I mean you can get a psychologist, you can get people to help you. About biology, you do need to have very strong bioengineering people. And oftentimes they are merging between them and the technology design is actually very challenging. Because oftentimes those are still very in terms of readiness for general public is still really quite behind. It's still coming here, it's still far away. So therefore they only build for specific cases. Specific case. As if VR and AR and this unit is appropriate because now it's starting to emerge into a more general public. So therefore everyone can think about different things. So I think that is real definitely. And also all this artificial health and things like that in the future when you get old, I mean probably your generation when you get old you probably have someone look up or some machine looking after you.
Yeah, it's already like you're talking about automated and scheduled food dispensers, pills, all that kind of stuff. So automated insulin and all that stuff, diabetics.
Oh yeah, and also I was talking about someone that created an dialogue to give you a mental sharpness. The robot that can read your motion. I mean that's what we're working on. Yeah.
Ethics is going to slow down almost like it does everything. Well, imagine going into a virtual environment and seeing a loved one is passed away. And you've taught, say, AI or something to your and you've just had videos and things, you've got their voice, personality, and with a group of subsets or other
Okay.
Build
Yeah.
in a virtual environment, and you can talk to a past loved one that's dead.
Yeah, you know, you've seen a movie called Transcendent, Johnny Depp. I think that, but that is about capture before the dead.
And also,
But not the later part of the movie. I'm talking about the front part of the movie. Yeah, which is you basically capture personality. But that's a little bit kind of quite science fiction. But I think you can potentially capture the big data you mentioned is quite relatively easy because if nowadays people are familiar still with just talking social network platforms, so you barely see face to face. So basically, your characterization of what you see on the screen, the packaging, what represent the people that you learn. So,
imagine when I'm maybe 50 years old, my dialogues over 30 to 40 years can be documented, can be looked at, can be reviewed, can be highlighted, and create another me. Just another access to that kind of information gathering, and so specific before. That's very attractive. Yeah.
but that is actually right now. You know, the systems are already looking at the personality for advertising, for money.
Monetization always comes into things. If it doesn't make money, no one's interested. So that's firstly the driving force of technology. You have to make more money, and eventually.
Yeah, but the privacy is always really great. Privacy. So suddenly they can duplicate you. And that's
Incoming methods. So are you familiar with the kind of big Google's AI, where it can actually answer phone calls with your voice when you're driving, and you'll actually like someone calling you, and they answer using your voice to say, "I'm sorry, I can't talk to you, I'm driving."
oh, I think I heard about that.
Okay, so if they replace that, I kind of recording so someone says, "Hey, would you like to sign up for this?" Your contract at the moment is tangible and call it away. So if you can replicate your voice, you can accept a contract over the phone. You can answer government, but they call you and say, "Oh, we need this information," or you can scan here, you can call up and say, "The shops are moving, you can send me $50 so I can get a cab back home." You know, oh, here's my card details over the phone. It's all, which is where they can start.
That's why I think a big company here, when they offer this kind of product, they have to be very careful. It takes a while, remember, it's pay on the phone to take off. Time to get people acceptance on the loophole. Yeah, but this is really, I think we're kind of moving very quickly.
And like everything, security is about 7 years behind.
Yeah. You believe that you are in there.
That's the thing. I look at the Internet of Things there, they're just saying, "Oh, we probably should put some security on these things."
That's right. All right, so let's continue. Okay. All right. So this lecture is about getting kick-started on the VR. Okay, so what VR look like. So I think the best, usually what I do is I show you really in the past different application to show you, because I think what you're about to expose inside the VR with this new gear is really about what current status will look like. I think you will get exposed to that. A lot of them are games, gaming, really fast-moving stuff like that. I don't think we have it, but if you have home computer, you can run VR. You can download Google Earth VR. I mean, that will be quite a worthwhile. It's take a little bit of bandwidth, but that's a good one. But this one is really about emphasizing on what the fundamental of what VR should look like. Some of the old terms they used to call, right now everyone call VR, but sometime in the past we call them virtual environments. If you read in some applications, oftentimes this day they just treat like equal, so they interchangeable. Okay. So this is the diagram we have before. Okay. So we are focused on the top right. Okay. So when you actually get inside a computer environments. Okay. So this is what we are aiming for. Okay, is there anything missing there? So this is a graphic from the 19 somewhere. So this is essentially you in the middle. Okay, so the tracker that I've been talking about, generally it doesn't screw into your head, but it's kind of part of what you're actually wearing. So in Oculus here, it's built into your visor, into your headset. Okay, you won't see them. You will see the actual sensor boom on the table that you need to learn to set up. But the sensor itself is actually embedded here, okay, inside the headset itself. So, and the whole thing here is a typical, very old-fashioned, but essentially the same thing. You have host processor, which is, in this case is a lab computer, and you have a data in which you render the model. In this case, Unity handle all this, so that's why you don't no longer have to deal with any of this. Rendering engines no longer need to worry. Everything run directly to the graphic card. Graphic card in the computer lab, in case you don't know, we have used to be the top of the line, but now it's not, but it's still very powerful. It's an NVIDIA GTX 1080. So that is more than what you actually need to run the VR. Okay, it's a little bit higher. The minimum requirement for the VR gear is a 1060. So now it's a 1080. I think the TI came out about a year ago, so, but that's still too expensive for that one. And now the NSX, can't remember the numbers. That's another competitor from, not competitor, another line of processing based on a different architecture of the graphic chip that came out. But I think the new lab won't have that. Okay, so I think it looks like Dell is still kind of at least a year behind the new card to test it on their precision tower. So, but GTX 1080s, you realize that it's actually handle all what you need. Okay, so that should be good. And of course, you display something on your screen. So in this case, you will see two optical lenses inside the headset. Okay, so in that case, you can see the image. As you move to a space you're tracking, you will see the image changing as you actually explore, in this case, go inside a virtual environment. So now, in the next few slides for today, the rest of this section, we'll talk about different applications to broaden up. So this would help with your current assignments when you give you some example. The VR is not just about game and a few things. So this one will branch out into different things. So this one, the first one, entertainment. So this one I don't really have to talk too much. I think you probably know more than me. So entertain everything, because this one is a game convention. You can Oculus and everything. So, and you can see here the person actually with immersiveness and a high response. This is, you feel a sense of presence inside very strongly. So a lot of ghost story, a lot of provoking, emotionally, it will be very effective. Okay, but remember, don't run away. Otherwise, you will got pulled back from the back of your VR headset. And this one is particularly interesting. You see anything around his band? Okay, I'm trying to get a hands on that, but I don't think they actually quite make it. It's called, I think it's called Omni. Essentially, here is sensor that because VR has one problem is that they can move beyond the cable. Okay, that's a standalone version of the VR, but that's still limited. You still limit by physical space anyway. Even though you have no cable, you still have a door that you don't want to run into. So what that means is that they create this kind of treadmill that actually put things around you and you're walking on the treadmill. Okay, so but the treadmill here is not on one dimension. You can actually change direction. So that's why it looks like a ring around you. Okay, so that one is supposed to be a lot of promise, and this is a kind of good example. I think they actually bothered kind of some problem with fabrication, so they couldn't get the price down where the market required them to be. They actually Kickstarted at about the same time with the first Oculus. They're supposed to be partner. They came out a few months apart. They're supposed to be partner, but Oculus take a different path, and this one gets still stuck. I think the company is still there. I think it's called Omni. Yes, but that's the kind of VR in general. So entertainment. The next one is simulation. This one is actually the most successful the VR has been done. Okay, this is commercially used. Okay, so you will see this in pilot, flight, or flight simulator. No one trained on the real plane first time. They're always simulation. This is a standard compliance. So this one is actually certified. Okay, so what I mean is that you have to pass this one, just like you have to pass a unit to get the degree. This one you have to pass a simulation to get to the next stage, you get the credit. And for these, this is not only applied to this one. In Newnham, there's a called AMC, Australian Maritime College. That's part of UTAS. They have a simulation too, but not plane. They basically control a ship on the chip dock. So, but their setup are much bigger, so they're supposed to have about a 2-story tall simulation. Okay, so in that case, they'll have a bridge simulator. They have a I don't know what they call, but the kind of what the captain would use, first officer. They will have a few all device. We have like this. This is all real equipment. Okay, a mock or it's real equipment that they use for the actual real plane. But all things they're driving here is a simulation. And simulation here, the screen they're looking up, it's not looking out to the world. This is actually a refit of the display to create an environment. So like you're a seat cockpit and you're just looking to a bunch of screen. Okay, but physical outfit of all these are real. Okay, and that's how industry take up. Okay, so this is another type of plane. So this is another type of simulation there. Okay, so which is this creating a little bit more in case that you have a bigger screen. Okay, so a bigger wide like helicopter, you have a bigger window. You basically look almost to the side. Unlike a commercial airliner, you practically look straight. So a small screen is relatively doable. But for this one, they were experimenting with a projector base. This is what AMC is using for their bridge simulator, because essentially the bridge is about double the size of this table. It's a big one. So therefore, their wall is about, I think it's about 10 meters away, but the wall is up that high. So the whole thing is projected quite real. It's not getting real when you actually poke your head outside the window. You realize actually that's the real floor. There's not the ocean. Yeah. So that is what they're using it. Okay. So as I said before, in this one, it's actually we are very good at procedural-based training. Okay. You're training, introducing situation, what to do, and you go to a proper step. Okay. Now, this one is also the early work that done by the U.S. Navy. What happened if you actually set up a parachute and you come in there and then suddenly something happen and then you have a harness everything, which is tied to a cable, which it actually can simulate the circumstances. Let's say what happened if your unexpected wind happen and you kind of flopple in the middle of the air, what you can do there. Even though I can tell that this is a glass from old generation, what you were looking for is a very tiny 20-degree field of view, which is probably this much. It's so very small, and the displays are not very bright. So essentially here, even that, it still has a promise for them. It's because it gives them a sense of, oh, this is what you could at least, what this researcher can see is how he would react to a stimulated environment. Okay, even though the environment is not as real. Today is much more real than this one. Yeah, but that is still a high promise there. Okay. So this is military has been jumped on this commercial airplane, marine is already into that space. Medical is also not far away. Okay, some of the early work they done out of this one. This one, that's why I was saying 20 years ago, there's a lot of this outward-looking project. This one tackle a problem with Parkinson's disease. Okay, so this is when your movement become interrupted. Okay, not physically, but actually your psychology and your visual system change. So therefore, you can't really go. You will see them walking steadily. Okay, so that is actually a little bit of a problem. Okay, so they're trying to tackle this in the HIT lab. They tackle this by projecting a VR set to a Parkinson's disease patient that actually looking. What he's seeing here is actually. Try to get my mouse there. You don't see my mouse. So what they were trying to see here is that little screen clone of what he sees, which is a chessboard, essentially a chessboard. And that's all it is. When he looks to the floor, he'll see a chessboard. So what that means is it allows him to step from one pattern to another, from black to white to black to white. So that's allow him to make the first step, which is actually the most difficult for the Parkinson's. So they're often going back and forth, and not really move forward. So that is actually their experiment with that. Okay, and believe it or not, I think this one is start to have a potential. Okay, so because this one you can see here the cable, everything. Okay, so you only can walk inside the lab, probably not in your home. So that means if you like to walk, you come here. Yes. So now, but nowadays with the device like Google Glass, which you would have heard about that 4 years ago. Now that is actually become a little bit more doable. Okay, let me pop up to a video that I think you will find useful. Okay, so I let you watch this one. Oh shoot! Let me just give me a sec. Not sure if this will work. But
I was diagnosed with in Parkinson's, all of your movements, and in fact everything about your body becomes constricted. To me, it was slowed down. When I would walk on the sidewalk, I would feel like I was walking through mud or quicksand.
let me restart.
Okay,
Okay.
disorder.
That's
I
a
was diagnosed
Google
in
Glass.
2003 with Parkinson's. All of your movements and, in fact, everything about your body becomes constricted. For me, everything slows down. When I would be walking on the sidewalk, I would feel like I was walking through mud or quicksand. Okay, class. Walk with me. They have developed an app for Google Glass, and it consists of a little screen and this plastic piece that you put on, and they give you little visuals to follow. I took it out for a walk, and it's great for a walk because the person who's demonstrating the walk, she's walking and you walk along with her, and then the screen disappears and the music just keeps looping while you're walking, because walking to a music is very helpful because it keeps you in a certain gait and you don't slow down.
Danceropedi offers free, specialized dance classes for people with Parkinson's. All of the strategies that dancers use to move and to control their movement and maintain balance and control their flexibility and use a wide range of imaginative tools to initiate movement, all of those tools can be useful for people with Parkinson's. As a teacher, it's impossible for me to be with each individual student once they leave the studio. Google Glass is, in many ways, the perfect technology for translating the information that we try to get across in class into people's everyday lives.
The exercise is really imperative to combat almost any kind of ill health. But with Parkinson's, it's particularly necessary because of the tendency of the body to constrict, just sort of twist in on itself. I think probably the visual keeps you honest in terms of the extent to which you put your all into an exercise. The dancers are so well trained and they do it so beautifully, you want to imitate them, and when you imitate them, you're doing the exercise better.
So that was
Parkinson's is a movement disorder.
so that was 3 years ago. So you can see that Google Glass-wise may have not hit the target it was aimed for. It does have a niche market in which a clever design and a very good mesh design allow them to make a use, because essentially one thing that Google Glass done well, maybe because they lost a lot of weight in Hayes' case, is that the form factor. Anyone can wear them. You don't feel like the intrusion in the space, except that the camera keep recording the space outside of it. Now the company is actually live, okay? So that means I think that's a good example that you show. Is that you get the technology to merge it. Remember my bridging in purple color on those two diagrams, technology and functional requirements and experience. This is a good example there. Hopefully they make it commercially. Yes. So that's to give you some idea. Okay. And by the way, if you're interested in Google Glass, we do have one. But I think if you want it permanently, that should be much cheaper. When it came out 3 years ago, it's $1,500. But nowadays, you can get it on eBay. It should be much cheaper if you have a winning idea. So this one is one that also creating a lot of media interest in this one. It's called, well, it's called pain, but it's pain reduction. Okay, so this is deal specifically with a patient with burn problem. Okay, when you get into a kind of fire accident, your skin get burned, you get treatment. Okay, the difficult part for this is basically you have to clean your wound, and you have to put in a plaster or a banner around it to prevent infections and getting disease in. The difficult part is not putting it on, is that you have to take, well, for example, if right now you have a cut, you put a bandage on, and you leave it for a few days and you take it off, it's no problem. But for a patient with a burn severe like that, when you wrap around with the bandage, what happens is usually is a cottage. You have to take it off because otherwise, because it's so thick into the very bottom of the skin. So what that means is if you don't take it off, it's going to try to eat it up. So you're going to kind of grow the tissue on top of what you actually bandage. So they have to take this out almost daily and reboot it every morning. So what that means, it becomes very painful procedure, okay? And but as painful that is, it's better than lose arm. But that is still creating a lot of things. So this is actually to show what is the pain, okay, while resting, okay. So in this case here is a morphine. So that's what they're traditional, try to ease the pain, okay, for people who are in this severe pain. So this is a participant. You can show the people saying, oh, okay, so pain rating is a little bit severe, which is in red here, but mostly under morphine components, it's actually moderate. Okay, the rest of it is moderate. So that means this is our old traditional way of doing things. Now, if the morphine is not adequate, inadequate, so what happened here is that you're going to get into this red zone, which is actually a lot of pain and more pain. And so that is something that actually, that's what they tried this study. My colleagues back in Seattle has tried to look for whether VR can do for that, using ability, immersiveness, attraction, draw attention to for the purpose of that. So this is from Seattle Hospital. Okay, so they participate in the project. So she has a headset, the patient. Okay, and the nurse is trying to treat them. Okay, and this lady are wearing some VR headset at that time. Okay, and of course all this is a wound components. So the right hand is being treated. So what it does is the left hand to playing around with what appear inside the VR. In this case, it's actually they call a virtual world, which is a world of snow. Okay, so that is the same. Okay, with this patient. Okay, this is a different part of the body. Okay, so you can see here the VR, and this is inside the actual treatment room. Okay, so what they actually see inside here, okay, is not a burning house. It's actually a more cold weather. In this case, is that what they see? So they sit inside what they call what's a snow world. Okay, so you basically sit inside a train. Okay, a train that you're the only passenger, and you're going around this mountain of snow. Okay, and basically all mostly white and everything, and that's it. And then you have this snowman, okay, that try to shoot you. So, and then basically you try to hold some kind of gun and try to shoot back. Okay, and then your train is going around and around, things like that. It's like a simple baby games. Okay, but that is actually what they found is quite useful. Okay, for them. So this one is a little bit of a cut from the MRI scan. Okay, so in this case is the one that pain-related activity during no VR. You can see the red. Red is mean pain, more pain. So this one you can see the reduce of sections. This is from his paper. So what that means is that it shows that actually they has experienced less pain. Okay, so with this is actually one of the things that supply into this is that the reason they pick this so that it actually they try to induce the visual stimuli to overriding the fact that they're actually inside the core environment, when in fact they hand practically in a very burning environments, very hot, and they feel. So this is a kind of subtle, and the lead researcher in this is a psychologist. So I mean, that's a core driving for that. It's not like they like snowman, not necessarily. The activity which are designed so it's easy to use. You don't need to learn much. You just keep shooting, and things like that. Okay. But the thing is that once you have the task, then subconscious, you experience psychology. In subconscious level, you experience that you're inside while you're doing this task, which is shooting this snowman, you actually start to believe subconsciously you're inside the core environment. And they found that is helpful. Okay. So that is a really thing that I learned from that. So that's to give a rise in quite a few of this one that believe that you can overwhelm the sense of human, okay, and then you can alter or changing ultimate experience of the user. In this case, it's spin inside the medical area. Okay, you can look it up on this work. I think he probably went. After that, he went on and do. I don't think he did commercially. But you can look in this. He's quite well known in that space. So this is some of those. Okay, it's really quite useful. Okay, so to show you that it's not about building apps. This is really about who build something that the user may not even know they're learning something, but in fact, it actually alters the perception of the real world. In this case, it's from being a burn patient, has a wound, live wound, into a more active, into a gaming, inside a cold environment. So, and that is actually a very clever way to do it. So another one here is attention consumption. Okay, so this is a designed distraction. Okay, this is some of these I try to show you kind of little odd things that it's not about entertainment, which I'm really not emphasizing. If you have a game unit, you can attend those ones. That one will aim for that. This one is really about anything else that gives you more right. So entertainment is still fine. I mean, it's in the unit. If you're really passionate about the game, you can make your assignment based on that. But I'm just trying to give everyone benefits. Sometimes you see something else that you like to do, simple to do. Because game is, if you're not in the game but you're doing game, most likely your game is probably not interested. So it's probably not a good way to go. So this one is a first patent that my supervisor patent when he moved from Navy Research to University of Washington. So it's called personalized displays with a TV built in and everything. So this is a marketing pitch, which of course didn't go too well. Okay, but this is what my Tom always claimed, that this is a precedent. Grandfather of Google Glass. So as you can see the concept here, like sunglasses, and you can watch the American football here. The problem with this pitch, which is the same with a lot of what you have in the past, is that you think you can see this. In the real world, this is really tiny. It's very single tiny, so you have to really make up who in there. So it's really not work that much. When you go out to projector, it looks like, oh, it's okay. I mean, the whole Google Glass is only like 10 degrees or 15 degree field of view, really tiny. Yeah, so therefore, it's good for just like that Parkinson thing. The whole movie is only, they have to design, so it's not too much detail. They just see the movement. I think that's the key for them. Key the movement, and then they believe in the movement, and they just move. I think that's the key. But to read very intensive, a lot of things, people are pitching like, oh, you can read car manufacturing, car repairman manual in there. So, how are you going to read that? It's just like that much. And so these are similar things. So, but it kind of gives you the idea of what they were talking about shipping. Because at that time, remember when this came out, I think 89, that's when the graphical user interface just emerged inside the public eye. So this is a way out. So there's a lot of investment into this, yes. But they find something interesting use for dentists. So that's it actually. Oh, while you're doing this, you might actually put something for the kids to look at. Yes, some cartoon, big things, or a simple thing for them to use, and keep them occupied. Because you go to dentist, you will have experience, right? Except that beside the sensation in your mouth, you find that, well, I don't really want to look at the ceiling or listening to the dentist talking. So in this case, they just find a use to put the things inside a component, inside this one. This one is called distraction. Okay, the same thing with the pain before. It's distract you from what is happening in the real world. Okay, so that should be another interesting way that you keep in mind. This one is same researcher that done the pain, basically the world, the ocean, the snow world. This is a phobia. Okay, this one is anyone have a spider phobia in here? Okay, so you probably want to take it easy. So this one actually is a spider phobia. Okay, so this one is actually it's classed as a minimum exposure. Okay, so in that case, is that they just keep exposing you to they use the fact because the spider here with the graphics like this, it doesn't look real. To normal people, it just looks like something that looks similar to spider, which doesn't look like, it doesn't scare you. It doesn't for normal people, but who actually have a phobia, this is just enough for them. Okay, so it's enough for them to spook, but not too much that actually make them to run away or something. So this is try to imitate what the real world look like. So you put it on, you see some spider walking. Okay, you feel like you're inside a kitchen. You see this and things like that. And of course, they design some activity. The trick for this one is that they have a tracker. This is a little piece of hardware that have a wire on it. Look like a little small thing that you can grab. And the researcher will hand this to the VR user, which you don't see them in person, okay, because they're put in the VR session. They just have to try to touch the spider, a virtual spider, okay? But the virtual spider here is co-located with the physical object, which is another tracker. You just think about it as a hand control, it's just put there. So you just think you're touching a virtual spider, which doesn't look real to begin with, but then essentially has a tactile feedback. You can feel like, oh, there's an object there, even though it doesn't have legs and everything, but you feel like, oh, that's something. And that is actually what their study is about. Okay, so I think this work is actually happened before the Snow World work. That's when they realized actually this one can get people to kind of get a sensation of this, even though the graphic, as they admitted, is not good. I mean, it just looked like some polygon moving around. It looks something like this, but it's not as realistic. Let's just put it that way. I think the later on part, the work done from New Zealand has this one in AR mode. So you put your hand up and you have a camera. You look at your hand and suddenly there's a artificial AR spider crawling on your physical hand that you see through the camera. And then I think that's a bit more spooky than this one. But this one is very first early work, probably 10 years earlier than that, to show that actually it could get into a subconscious. Okay, but this is a very clever technique. The one inside this one I forgot to mention. You see that little object hanging in the floating, with a little bit legs here. It's not a spider legs, but that's a tracker object. So I mean that's know precisely where they are in space. So I mean if you put a virtual model on that, you see that virtual model is at the same location. Okay, so that's when they allow you to go and grab, touch them, things like that. So that's a clever way to go about it. It's not just a visual stimuli and try to do only on visual base. So this one is actually there. So I think they did some simple study, like if you come here, how many exposed. So this would be kind of like you expose them small. In the next few weeks, they come back for a little bit more on that. A spider become more aggressive toward you or something like that, more like they walk toward you or things like that. So that kind of thing, and they try to measure whether actually the resistance is working. Okay, whether there will be a way. And another one here, I think you would have this in real world already. This one is a sphere of height. Okay, so in this case, you put it there. You see nothing but glass, but you can get this in the real building nowadays. But you can get this in the real world, so in the VR. So that is actually a very good way of testing whether VR has a good visual effect. Because when you put the people on and you have a hole here that have a glass on, you will see them dangle around the edge like that. Yeah, so what that means is that it shows the effect of what VR has to the person. If they just don't feel that at all, I mean, either the VR is nothing wrong or there's something wrong with them. So that means like they never really fear height or something like that. And another one here is public speaking. So this one is actually an interesting one. So you put it there. As I said before, these could be simulated environments. This is what he sees. And this is what I think there's a project that might be possible that actually you can simulate their class. It could be a class of a younger student when they actually can control their emotions. So they have aggressively attack the teacher, not attack, but the kind of raise attentions and then how you manage. So this is like a teacher learn how to deal with a little bit of aggressive classroom, more younger student. Okay, so but this is more general public. Okay, so some of the visualization here also being used. Okay, so this is about putting you literally put you inside the VR environment or inside the data. Okay. So this one is basically inside a big projection system. Okay, so this one is biometric information. So it's still this one is still flaky. In this area, it's still very hard to quantify what visualization in VR, how well they're better than normal what you see in infographic that you have on the desktop. This is the one I built in the HitLab. I think we build one here later early next year. Okay. So the big wall has a big display and have everything. I think you would have heard our discipline head, Professor Byung Kang, is showing about project base. So I think we're building at the basement next to Harvard Room, there was a business school, and that converting into our project base for our MITS and BICT students. So we're throwing a lot of money into those space, including some of this I built at HitLab in Newnham. We build similar thing here now. Okay. So next year you will have more project, more fun with it. Yes. So I'm responsible to keep out the list of things that you will. So I throw a lot of hardware in the list. So you have those. But you will get first exposure inside our unit now before. So this is what, in terms of contents, okay, let me just forward back. In terms of contents, VR contents is actually one of the weakness part. It's that there's no particularly, basically there's no one know precisely what useful, how useful. I talked about killer app before. So that's what is actually missing. A lot of this is VR contents is a key. There's quite a bit of video, but let me just go through it quickly. So before this one, spherical recording, this is a few years ago, but this is to show how you experience the music in the future. So in this case, it looked like a warp, but essentially when you put in a VR headset, this one will look surrounded. Okay. Or actually, if you access the website and the slide to the mobile phone, it's actually becomes, you basically move your camera through. Okay. This is just happen to warp everything into one. So that one, and then the next one, this one is the car company trying to make a sale. This one I can interact with a little bit. So instead of you just watching a fix, so in this case now you can use your mouse and keyboard and moving different things. So this is a 360. Nowadays they have plenty of those. Okay. We just don't have that in our units, but you can get a spherical. This one is just simply video. Yeah. And then you can look at your own feed. We should look like that. It doesn't look much at the feet, but yeah, essentially that's what they take out the passenger seat and putting a 360 camera on top of it. Okay, so hopefully that gives you some idea. Okay, so the content is really still really very much. That's why you see a cloud-based solution that started popping up in nowadays, because that's when the platform in which the big company try to get access to that and let you deposit. Deposit all the contents there, they become kind of a center for those things for you. But then there's quite expensive contents there, so maybe it's require quite a bandwidth. Okay, nowadays the solutions are much cheaper than this. This one is when it came out, it's $60,000 per head. Okay, so that is a little bit expensive. Some of these will come online. There's a 16 GoPro synchronized and sync. Yeah, the key here is to synchronize it. You can do now with a phone. They're doing a prominent display. However, you have to do it one shot at a time and stitch them together. What that means that if someone walking to your scene, he'll appear, his leg will appear here, his head will appear here, and fractional across it. And this is just kind of commercial one, and they grab in one, and then it actually have a video and synchronize between different frames. Okay. And the VR headset here, all this, we just don't play with HTC. I think the setting for that is more a little bit not suitable for lab, because it requires a high ceiling attached and also a tripod and things like that. It's just not working. The one we're using, Oculus, the one that is not shown in the picture on the top right here is a sensor, which is put on the table, and that's what makes it suitable for the lab. Okay. And this one, as I said to you before, mixed reality, Microsoft. So we have a few of these things you can play with. This one doesn't require external on the desk, but it's still tie cable to it. And the one in VR, the standalone. So we got the two now. Okay. So the Oculus Go, we have a couple of those. We got a couple of these Lenovo Daydream. So that allow you to move quite freely. So when we get there, I think you have a little bit of fun there. But remember, the processing power is a bit slightly less because everything is run off the unit. Okay. And this one has not come out. I think it came out in China. It's already come out in China. If those of you go back to China, you might grab one and then bring it back here. Otherwise, we'll just wait them next year for them to be available in Australia. Okay. All right, so any questions? Oh, good. So now I think those of you, how many of you has tutorial at 11? Okay, so I think, yeah, we just make our way to there.
So with the Oculus, I've got a HTC you don't need the sensors up in the room.
Oculus need a sensor, but it sense, yeah, it's on the chip. So the range of tracking for the wide line.
Yeah, so I've got the five behind me. I was thinking of like in the lab, hang on. It's not gonna work.
In the lab, we used to do a mobile version of that, but it's on tripod. But in the lab,
It's not practical.
it's not practical. So that's why we went with the Rift.
Yeah.
Oh. Our exam will be an A4 note, A4 size, and then you can write on double side. It's just one piece.
Right?
You can write, you can print.
So for the every question, we just need to justification and
Yeah, just like yesterday.
our okay. And you mean that for the HD for the assignment, we need to have we need to describe in more detail for the key technology and the.
Yeah, you should have a bit of understanding into that a bit of technology there. So that means that HD, you would expect people to look beyond what they're saying. They might just say voice recognition. So if you get voice recognition, they might actually disclose in the paper. If there's a paper attached to it that actually talk about the techniques and things like that. But you don't actually require to understand the technique.
Okay.
But dig a little bit deeper. Some of them is possible, some of them might not.
You mean as for the design part, you said we need to be more expert on design.
Oh, you should, not more expert, but you should emphasize on the design, give a lot of thought in the design, because if the technology is not what you're digging into, it should be the design, why we design this way. And that's why we talk about justification for the design. Yeah, it's really about justification, but it's not about teaching you to be an excellent designer. Design actually requires some natural creativity.
And you said for this motivation is an example for the assignment 2 and 3. So I'm not sure I understand.
Oh, so this one is really just a good setup for just a good example. If you actually start with some problem, let's say you pick this as a problem for your assignment 2, and the way you design the thing, that's the way I design. So it kind of gives you an example of how to do it. So that means you pick a problem, different problem, not this one, then you go a similar step to this.
Okay, because this page have too many links and too many data, so we need to click.
Yeah, it's something like that.
So we need to
That's right.
this.
Yes, sir. And then in your report, you were talking about these, what you mean by that. This is just a slide, so that means it doesn't all have the content. Yeah.
And on the human side, long-term services, you said for the design part, we need to consider the.
Yes, sir. Yes, sir. So the design part is merging between technology and the application itself, like too many click. Technology side, what technology you use, and design how you get there. And that's what the magic map is. So design at the very end, that's the design output. So you have to look for both stuff.
Okay. So this is the.
Yeah, this is the terminology. It's not. It's just for you to read and understand it, what that means. Yes. So it doesn't have to address all.
Okay.
Yeah.
Will you be going straight to the tutorial?
Yeah.